is my answer less than 0.05? If it is, then it's significantly low or significantly high. So is that answer the 0.841 less than or equal to 0.05? So is 84.1% less than or equal to 5%? No. So we can say that it is not significantly low. We can't say anything about being high. We can't say anything about anything else. We just know it's not significantly low. Yes?
Would there sometimes be a question where it says or less and it's actually going to be significantly high?
No. Because we can only check significantly lowness when it's or less. We can't check significantly highness unless it's or more. I love y'all. Y'all have the best questions. All right, now we're going to talk about some gambling. Yeah.
When on a table, when they ask for like 5 or 4, there is nothing like and like.
Because you can't have 4 sleepwalkers and 5 sleepwalkers. You can only have 4 sleepwalkers or 5 sleepwalkers. Good question. Okay, so now we're going to do some gambling. This is why Ms. Cooper does not do the gambling. Okay, we're going to be talking about that expected value again. And there's 2 ways we can do expected value. We've already learned that expected value is the same as the mean. Okay, so I'm going to show you, and I don't care which way you do this. We can either say that expected value equals the mean. And if you do it that way, then you're going to do like what we just did. You're going to do the L1, you're going to do the L2, you're going to do stat calc of L1, L2, one var stats, and you're going to look at the X bar, and that's going to be your expected value. We cool? So if you want to do it that way always works. Now, there is another formula that you can do expected value, and I'm going to show you both of them. That is value times probability of the first event plus value times probability of the second event. And if there's more events, we would just keep doing that. Where this is the value and this is the probability. Just like we did before. If I scroll up to right here, this would be my value. This would be my probability. So we would do value times probability plus value times probability plus value times probability plus value times probability. That would give me my expected value. Well, your calculator's really doing that for you when they're giving you the mean. Okay? So I'm going to show you both ways, but the hardest thing is setting up those tables. So once you get that table set up, most people, once they get that table set up, they're like, let me just plug it in the calculator. I'm not even going to do that. But I'm going to show you both ways because my math lab will show you both ways. All right, in the Ohio Pick 4 lottery, you can bet $1 by selecting 4 digits between 0 and 9 inclusive. Inclusive means I can choose 0 and I can choose 9. So I can choose all numbers 0 to 9, including 0 and 9. If the same 4 numbers are drawn in the same order, you'll win $5,000. So I give the little cashier $1, and I get to pick 4 numbers. So this number has to be a number between 0 and 9. This number has to be between 0 and 9. This between 0 and 9. This between 0 and 9. I give her $1. I pick those 4 numbers. In order for me to win $5,000, my 4 numbers have to be in the same exact order as what they call out. Cool? So, first question. How many different selections are possible? How many selections are possible for this one? 10. Because they were 0 to 9. Okay, so how many different possible selections? 10,000. You with me? Bringing up nightmares in the last chapter. What is the probability of winning? 1 out of 10,000. Because that's what makes me happy over total. I know. Nightmares. This morning coming to school, I was listening to 93.7, and they were playing a game called High-Low. And they said, you pick a dollar amount between $500 and $1,500. So the first caller calls in, and they pick a number between $500 and $1,500. So you call in and say 673, and they'll say higher. So then the next person calls in and says 729, higher. And then the next person calls in lower and higher and lower and higher. And so the radio guy said, and eventually somebody's going to win, as long as they listen and they narrow it down. Well, the radio broadcaster said, the odds of winning are 1 in 1,000. And I wanted to scream at him because I'm like, that's not the odds. Well, between 500 and 1,500, how many options do they have to choose from? 1,000. And how many people are going to win? So it's not the odds of winning, it's the probability of winning. Odds would be how many win over how many lose. So the odds would be 1 over 9,999. He was doing probability of winning and not the odds of winning. I had to kick him. This about called in, and I'm like, no, I'm not going to do it. That's why he's a radio broadcaster and not a math teacher. Okay, if you win, what is your net profit? Now, net profit means what do you bring home?
9.
Oh, yeah, mine was
You won $5,000, but you paid $1 for that ticket. So you actually brought home $4,999. This is what you won, but you had to buy a ticket. Yay? So this is when people say, I won $500 on the lottery. And I want to ask, but how much did you spend on tickets? Because you really didn't win $500 if we take out all the money that you spent on tickets. Okay? Now, it says find the expected value. So we have two things that happen. We have either you won or we have that you lost. So we have value and we have the probability. So either you won or you lost. So what is the value if you won? Who? The 4,999. Because you didn't win 5,000, you won 4,999. And what is the probability of you winning? 1 over 10,000. Now, what is the probability that you lost? What's the value that you lost? So if you do not win the lottery, y'all, heaven forbid, it may happen, how much money are you going to lose? So do I put 1 down? What am I going to put down here? I'm going to put down a -1 because you spent $1 for the ticket. This is a positive because that's what you're putting in your pocket. The other one's a negative because you spent the money. You're out $1. Now, what is the probability that you're going to lose $1? Give it to me. Give it to me.
9,999.
If you win 1 out of 10,000, you're going to lose the rest of the time. 9,999 out of 10,000. Win plus lose equals 1. So if you win 1 out of 10,000, that means you're going to lose. Y'all with me? Now, if it were me, I'd stop right here and I would go to my little L1 and L2. and I would find my X bar. Let me show you. So this is gonna be my L1, and this is gonna be my L2. So I'm gonna go to my calculator, I'm gonna do stat edit, go to the top, clear enter, go to the top, clear enter. So 4999, and then in the next one I'm gonna do -1, not subtract 1, but -1. Negative's down here. And then in the other one, watch this, 1 divided by 10,000. It's okay, don't freak out on me. And then 9999 divided by 10,000. We good? Then I'm gonna do stat calculate. I need to know the mean, which is the variable, one variable stats. I need to make sure there's an L1 and an L2, because I have two lists. And I'm only worried about the mean, because the mean is the same as expected value. So y'all, if I spend $1, I should expect to win or lose, because this is negative, I should expect to lose 50 cents. So for every $1 I spend, I should expect to lose half. So if I spend $100, I should expect to lose 50. Yeah. If I spend $1,000, I should expect to lose $500. So that is what I should go in expecting to this lottery. That I should expect to lose half of what I put in it. Now, if this was a positive number, this wouldn't be a lottery. Because they don't want you winning money. They want to be making the money. Does that make sense? I'm not even going to show you the other formula because this is the easiest way to do it. All right, let's look at another one. Life insurance. There is a 0.9968 or a 99.68% probability that a randomly selected 50-year-old female lives through the year. Most 50-year-old people are pretty healthy. You know, you're going to die when you're 80, 90, 70, something, not 50. So she's pretty healthy. You know, she's probably not going to die this year. A life insurance company charges her $226 for insurance to live through that year. If she does not survive, they'll give her not give her, because she's dead, but give her family $50,000. From the perspective of the 50-year-old, what are the values corresponding to the two events of surviving and not surviving? Okay? So, if she does not, well, let's start with survive. If she survives, tell me about her money. Did she pay money or did she get money? She paid. How much did she pay? So it would be a negative $226. So if she makes it through the year, she wrote them a check for $226 and she lives another year. Correct? If she dies, tell me what kind of money we have.
So would you subtract
Yes.
Monthly, or just the 226?
It's going to be $226 for the year.
Oh.
So it's going to be the $50,000 minus the $226 because she paid that at the beginning of the year and she died somewhere during the year. So $50,000 minus the $226 is going to give me that if she dies, there's going to be a 49774. We good? So that's part A's answer. We have two answers for part A. If she survives, she's out $226. If she dies, her family gets $49,774. We good? Now, for the expected value, we need to do value in the first column and probability in the second column. What are our two events?
Living and dying.
She either lives or she dies. And we just came up with the values. We just said that if she lives, she's out $226. If she dies, her family gets $49,774. Now, we want to know what is the probability that she lives. Right here, they told you. This is the probability that she lives. So there is a 0.9968% chance that she lives. How are we going to figure out what's the probability that she dies? Good. Live plus die equals 1. So if there's a 0.9968 that she lives, I want to know that what she dies. So I'm going to do 1 minus 0.9968. So there's a 0.0032% chance that she dies. Okay? So now I am ready to go to my table because it says what is the expected value. So I come over here and I do stat edit. I go to the top, clear enter, go to the top, clear enter. So my first one is going to be a negative 226. The next one is going to be 49,774. The probability that she lives is 0.9968. The probability that she dies is 0.0032. And expected value is the same thing as the mean. So we're going to do stat calc, one var stats. We are doing it for 2 lists, so make sure you have L1 and L2. The mean is the same thing as our expected value. So this is what we should expect to happen. Okay? So what does that mean?
She expects to lose $66.
We should expect her to lose $66. Her, meaning the woman. So what does that mean for the company? We should expect the insurance company. So if she loses $66, what is the insurance company going to do? They're going to make or earn $66. Because y'all, the insurance company is in business to make money. And the last question says, can the insurance company expect to make a profit? So this was part B, this was part B, and this was part C. That if the customer's losing money, that means the business is making money. Cool? That wasn't that bad, was it? Now, the last section, 6.1. This is actually fun. We've done normal distributions before, haven't we? Normal distribution, okay? This is the standard normal distribution, okay? And I briefly mentioned a uniform distribution. A uniform distribution is if I said, I asked y'all how many people like green, red, and blue. 4 people said they like green. 4 people said they like red. 4 people said they like blue. That would be a uniform distribution. A uniform distribution means everybody said the same amount. Okay? Now, these 3 bars represent what percent? 100%. So we would take 100% and we would divide it by 3. So each one of these bars would represent 33 1/3%. With me? So if there were 4 bars, we would do 100 divided by 4, and each bar would represent 25%. Okay? So that's what this is talking about, that a uniform distribution is when, and this is a lot of fanciness, but it's when every bar represents the same amount. So, they call it a density curve, which really it's not a curve. So if I draw right here, I have 1, 2, 3, 4, 5 bars. And the area under all 5 bars bars is 100%. Okay? So, if the area under all 5 of these bars, all 5 bars equals 100%. So how much does each bar equal? 100% divided by 5, or 20%. That's where this came from. 0.20. That can say 20%, that can say 0.20, or that can say 1/5. Those are all the same thing. So, hold on, let me get back to my little, the ham sandwich I just do. There we go. So that 20% is what's telling you over there. And the way they did it is they just said, I have 5 bars and it equals 100%, and I got to split it evenly because they're all the same size. If I had 3 bars, I would divide it by 3. If I had 4 bars, I'd divide it by 4. So, find the probability that the waiting time is less than 4. So, less than 4 is going to be how many bars?
4.
4 bars. Okay? So, we have 4 bars, and how much is each bar? 20%. So, that represents how much total? 80%, or 0.8, or 4/5, according to whether they want a percentage, a decimal, or a fraction. Greater than 3 minutes. How many bars are greater than 3 minutes? 2. Rank, rank. So that's 2 bars times 20%. So that's 40%, or 0.4, or 2/5. So really, and I'm giving you, and I'll give you something in just a minute. So from 2.5 to 4.5. So this is not a pretty thing. So what you can do is you can say 4.5 minus 2.5. That's 2 bars times 20%. That one's going to be 40%, or 0.4, or the 2/5. Now, let me give you another example. What if I said between 1.25 and 3.5? Well, that one's a little bit harder because it's harder to say, oh, that's not a whole bar, that's not half a bar. So if I give you one that's ugly, you're just going to subtract them. 3.5 minus 1.25. So if I come over here, it's going to be 3.5 minus 1.25. So that represents 2.25 bars, and I'm going to multiply it by 20%. So that's going to be 45%, or 0.45. Does that make sense? 45%, or 0.45, or whatever that fraction is. Cool? Do that one. All right. Now, this last one sounds kind of crazy. It says draw, let me come down here. It says draw the uniform probability density curve. Now, we're going from 5 to 10. So how many bars should we have?
5.
So we're starting at 5 and we're going to 10. So 6, 7, 8, 9. And we know that it's going to be straight across. Right there. And I need to know what this number is, okay? That if I come down, and I come down, and I come down, and I come down, that gives me 1, 2, 3, 4, 5 bars. So to get this number, it's 100%, which is everything under the curve, divided by 5 bars, which is going to give me 20%. So this number is either going to be 20%, or 0.2, or 1/5. If it was 4 bars, we would do 100 divided by 4. If it was 2 bars, it'd be 100 divided by 2. Y'all with me? So, what is the probability between 6 and 8? How many bars? 2 bars times 20%. or 0.4, or 2/5. What is the probability between 5 and 8? 3 bars times 20% is 60%, or 0.6, or 3/5. You're not gonna have to give all the answers. My math lab will say, I either want it as a decimal, I want it as a fraction, or I want it as a percentage. What is the probability that it is less than 6 minutes? 1 bar times 20%, which is going to be 20%, or 0.2, or 1/5. Let me throw another one in there. What is the probability that it is between 1.4 and, excuse me, I don't even have a 1.4, 5.4 and 8.68? You would do 8.68 minus 5.4 and then multiply it by 20%. So if I come over here, 8.68 minus 5.4 times 20%. So that one would be 65.6%.
And why did you do 20%?
Hold on, I'll go back over there. 3.28 equals 65.6%, or 0.656. You take out, so it told us to go from 5 to 10 in the directions. And so between 5 and 10, we have 6, 7, 8, and 9. So that breaks me down into 5 bars. And the area under the curve is 100% divided equally among 5 bars. So I did 100% divided by 5 bars. So that means that each bar has to be 20%. So let me give you one more example. I'm not going to do any questions with it, but what if I said I had a uniform probability distribution between 10 and 13. So if I have 10, 11, 12, 13, how many bars is that? It's 3 bars, and all of that always adds up to 100% because probability of everything is always 100%. So if I do, let me do 14 because I don't want an ugly number. Let me go to 14. We're at 14. Okay. So that's going to be 4 bars. So 100 divided by 4 is 25%. So that means that this number is telling you how tall they are. So that height is either going to be 25%, 0.25, or 1/4. Yay? And if I would have done 20 to 22, how tall would it be? 100% divided by 2 bars. So this would be 50%, or 0.5, or 1/2. Cool? All right. Now, we have talked before, so that was the uniform distribution. We have talked before about the normal distribution. What was this called? The who? Mean. And what was this called? Standard deviation. Look at y'all. This is called the mean, and this is called the standard deviation. Okay? The mean and the standard deviation. So this is the normal curve. And we've already talked about this. The only difference now, and these are actually a whole lot easier, instead, these are called, when you are dealing with a standard means uniform. When you are dealing with a standard normal distribution, your mean is always equal to 0. Your standard deviation is always equal to 1. Period. So your mean is 0, your standard deviation is 1. So it's kind of like a standard, it's a normal. Your mean's not gonna be 100, your mean's not gonna be 450, your mean's not gonna be 1,000, your standard deviation's not gonna be 2.6. Your mean's gonna be 0, your standard deviation's gonna be 1. This is normal.